Chapter 14, Number 13. The three waves A, B, and C, as shown in the figure below, propagate on strings with equal tension and equal mass per unit length, which immediately tells us that because of those two things, equal mass and equal mass per unit length, it means V is the same for both of them, for all of them, because V is square root of Ft over mu. All right. Rank the waves in order of increasing frequency, then in order of increasing wavelength, and then in order of increasing speed. Well, we accidentally just did C first, which is A equals B equals C. The speed is all the same. And then we can do A, and we can say which has the greater frequency. They don't really make clear here. We assume that this is a height versus position kind of graph. I guess it wouldn't matter that much. But in that case, then we can just read the wavelengths. And so we'll do part B first. Part B is going to tell us that we have, well, that's one wavelength for A, and that's one wavelength for B, so clearly B is greater than A. And then this looks to be intermediate, because there are, if you look here, there are 1, 2, 3, 4 complete waves. Here there's 1, and here there is 2. So B is greater than A, but C is also greater than A, and so we get something like that for lambda. And then finally we can say, well, the frequency is the wave speed over lambda, so whatever happens to frequency, to lambda, the opposite happens to frequency, which means that we get A is greater than C is greater than B. I suppose it's legitimate to pay attention to that. They said they wanted increasing frequency, which is opposite to our usual. So we really have that B is less than C is less than A, which of course is the same thing. And then part B tells us that A is less than C is less than B. So just to accord with the textbook's order.